Okay, example 4. Example 4, 5, and 6, they are about charging and discharging. We're going to see what happens when you charge up a capacitor and what happens when you discharge it. Okay, when you use up the charge, the energy that is being stored in the capacitor. So consider the circuit shown in the figure where C1 is 50 microfarad, C2 is 25 microfarad, and V is 25 volt. Capacitor C1 is first charged by closing switch S1. So now what happens in this circuit, you are actually split it into two loops. Loop number 1 here and loop number 2 right here. So what you're going to do, you don't look at this circuit at once. You look at them one by one. Okay, so start from the first statement, which is from here, okay, to here. Capacitor C1 is first charged by closing switch S1. So initially, the diagram shows you both S1 and S2. Now both are open. So what you're doing, now you close switch S1. So when switch S is closed, okay, S1 is closed, you are charging up capacitor C1. And after that, you open up the switch, means that you disconnect it from the power supply, from the battery. And then by closing S2, you are now charging C2 by using C1. Okay, so we're going to look at them one by one. First of all, we're going to look at what happened when S1 is closed. So when S1 is closed, okay, this is how our circuits look like. This is your S1, and then it is being connected to the battery, the power supply, and this is your C1. Done. You don't have to look at S2. You don't have to look at C2. Why? Because if S2 is open, means that you disconnect the C2 from the circuit. So what we're having right here is just S1, V, and C1 in the first part of the questions. So we're going to see what happens when S1 is closed. So if you look at the question now, calculate the initial charge acquired by C1 and also the final charge on each capacitor. So we want to see how many charge can be stored in C1 when S1 is closed. So how? If you look at this connection, when you charge up the capacitor, this one would be negative plate and here would be a positive plate. Negative plate being connected to the negative terminal of the battery, positive plate being connected to the positive terminal of the battery, meaning that now this is a parallel circuit. Okay, a parallel circuit. When you have a parallel circuit, VC is equals to V. When it is fully charged, meaning that is equals to 25 volt. And then C1 we have right now is equals to 50 microfarad. Therefore, by combining these two pieces of information together, okay, you obtain Q1, the charge stored in capacitor 1 when S1 is closed. That is equals to C1 VC, which is equals to 50 micro times 25. So Q1 is equals to 1250 microcoulomb. Okay, microcoulomb. So that is what happens in the first part of the question when S1 is closed with S2 open. What happened next? Now it tells you S1 is then open and then S2 is closed, closing the switch S2, meaning that now you connect the capacitor C1 to C2, but you disconnect the battery from the circuit, from the system. So now with S1 open, okay, and S2 closed, our diagram will look like this. So this is your S2. It is being connected to C1. And then here is being connected to C2. All right, here is being connected to C2. Okay, the information that we have right now is a C1 equals to 50 microfarad and C2 is equals to 25 microfarad. These two values, they will remain constant. Why? Okay, it doesn't matter which loop you are looking at, because now C1 and C2, you are looking at the same capacitor, you're using the same capacitor and you didn't modify it. You didn't change the physical structure of the capacitor. All right. So as long as you're still using the same capacitor, then C1 and C2, the value will remain constant unless you modify the physical structure of the capacitor. So you have C1 equals to 50 microfarad, C2 equals to 25 microfarad. Then how about the charge? Well, the moment you close S2, okay, C1, it will have a Q1 which is equals to 1250 microcoulomb. Whereas initially Q2 is uncharged, therefore it is equals to 0 microcoulomb. This is initial state. Okay, this is initial state. Initially, okay, initial state. Not the final state yet. That is not the values that we want. What we want is after you've charged the capacity to, after both capacitor, they come with same potential difference. Now what does it mean? It means you can no longer use 25 volt in our second circuit. Why? Because when you close S2, C1 will be used to charge C2, meaning that V1 will drop and V2 will increase. Okay, it means that V1 will drop and V2 will increase. So you can no longer use V equals to 25. It is not valid anymore. So we need to identify what is the new V in our questions right here. How? Well, you look at the total value. The easiest thing to identify the new potential difference is by calculating the C effective and also the total charge in the system. So C effective is equals to, now two of them, they are being connected in parallel. Therefore, it is equals to C1 plus C2, which is equals to 75 microfarad. And now I'm going to look at the total charge in the circuit right now. Now, since you disconnect the battery from the circuit, you are removing the source, the power, the supplier from the circuit. Okay, you are removing the supplier of the charge. Therefore, the total charge in the circuit right now, okay, it is just equals to Q1 initial plus Q2 initial. Okay, you won't have additional charge in the circuit anymore. Why? Because there is no more supplier. All right, so total charge in the circuit right now is 1250 microcoulomb. That's it. Okay, it is equals to the total charge at initial state. The moment you close S2, the initial charge in C1 is 1250. The initial charge in C2 is 0. Therefore, total is 1250. By using these two pieces of information, you can then identify the new potential difference across the capacitor, okay, across this circuit. So V final, okay, or I'm going to call it V prime, it is equals to Q total divided by C effective, the new potential difference across C1 and C2. Remember, you can no longer use 25 volt. Why? Because the moment you close S2, V1 will start to drop and V2, it will start to increase. All right. So it won't be able to maintain at 25 volt. That is because you have no power supply in the circuit. Okay, so when charge leaves C1, V will drop. Based on the equation, based on the equations, C equals to Q over V. So V and Q, they are proportional to each other. So when your Q drops, when Q leaves C1 and move towards C2, okay, so your V2 will increase, your V1 will decrease. So what are we going to see right now? We want to see the final value. So V prime equals to Q total over C effective. Or if you don't want to use V prime, you can also call it V final. Okay, V final. All right, so final. So it is equals to 1250 divided by 75 micro. So you will obtain 16.7 volt. Okay, 16.7 volt as their final value. Therefore, V final is equals to my V1 prime, which is the final value, okay, equals to V2 prime. Because Okay, because of what? Because they are being connected in parallel. So 16.7 volt, right? So I got this relationship because I know now both my capacitor, they are being connected in parallel. So once I have the final value, I have V1 prime, V2 prime, I have C1 and I have C2, I can then proceed to calculate the final charge on each capacitor. So Q1 final is equals to C1 V1 final, which is equals to 835 microcoulomb, and then Q2 final, which is equals to C2 V2 final, which is then equals to 415 microcoulomb. So that is the final answer. All right, that is the final answer for example 4. Q1 initial, Q1 final, Q2 final. Okay, so now I'm done answering the questions. Now, how am I going to check whether my answer is correct or not? You look at the final value, okay, final Q1 and final Q2. Final Q1, I have 835. Final Q2 is 415. When you add them up, total charge becomes 1250. So yes, it makes sense. Why? Because now these two capacitors, they are being connected in series. And when they are being connected in series, we know that Q total equals to Q1 plus Q2. So by adding them up and you will see that whether they are equals to the initial, the total charge in the circuit or not. All right, so Q total equals to Q1 plus Q2. Q1 835, Q2 415. When you add them up, they becomes 1250. So yes, now you have the right answer. Okay, you got the right answer. If when you add them up, they are not equal to the total charge in the circle, then it means you got the wrong answer. There must be something wrong in your calculations. There must be something wrong in your concept, right? So that is how we check whether we got the right answer or not. So total charge 1250. You try to add them up and see whether you got the right answer or not. All right, so that is the answer for example 4. Now I give you 3 minutes to write it down, okay? Because we have 3 things to calculate: Q1, Q1 final, Q2 final. So 3 minutes for you to write it down. If you have any questions, you may ask. Okay, if you have any questions, you may ask. All right, so I hope you guys can understand these questions because it requires a bit of imaginations in order to answer these questions. And of course, the whole thing will become so much easier if you sketch the diagram. That's why I always encourage my students, especially you guys, to sketch the diagram. Okay, this one, this diagram, and also this diagram, so that you can see what happens. You can see whether you got a supplier in the circuit or not. You can see what is going on. Which one is is undergoes a charging process? Which one undergoes discharging process? So obviously, in this blue color diagram, C1 is discharging and C2 is charging. It's being charged, and it's being charged by another capacitor, not the power supply. All right. And when C1 undergoes a discharging, V will drop, therefore it cannot maintain 25. And if both of them, they are being charged by the power supply, then the voltage will remain at 25 volt. Okay, that is the examples that we have seen before. Example 1, 2, 3. When both capacitors, they are being charged by power supply. Now in these questions, you remove power supply, you let C1 charge C2. So at this point, at this moment, your C1 undergoes discharging and your C2 undergoes charging process. So there will be a changes in the potential difference across the plane. All right. So be extra careful when it comes to this type of questions because changes is happening in both capacitor at the same time. And both of them, they undergoes different process. That is a crucial part. So example 5. Now example 5 is a bit similar to the previous question. Now what happens right here? You have a capacitor 10 microfarad is charged fully by a voltage of a 6 volt. Okay, so this is one case. Okay, this is what happens in your C1. And then a 20 microfarad capacitor is now being charged by another power supply, which is equals to 50 volt. So this is what happens in your C2. Okay, this is what happens in your C2. And after that, two capacitors, they are being disconnected from the power supply, and then you connect them to each other. With positive charge plate of both capacitors connected together and negative charge plate being connected together. Now, what does it mean? If positively charged plate connected together and negative charge plate connected together, then it means you connect them in parallel. All right. So if you connect positive to negative and positive to negative, then you are connect them in series. So we look at the diagram. So let us see the first one. Okay, what happens in C1? Okay, what happens in C1? Now you have a circuit. This is your C1. This is your power supply. Okay. Power supply V1 is equals to 6 volt. C1 is equals to 10 microfarad. Now you fully charge it. When you fully charge it, your Q1 is equals to C1 V1, which is then equals to 60 microcoulomb. This is what happens in C1. What happens in C2 right now? Okay, now you have a C2 here. C2 is equals to 20 microfarad. And then you have a V2, which is equals to 15 volt. So V2, C2, now you connect them like this, and then you charge C2 with V2. So Q2, the charge stored in capacitor 2 right now, it is equals to C2 V2, which is then equals to, oops, I put two equal signs right here. So the Q2 is now equals to 300 microcoulomb. All right, so now you have Q1 equals to 60 microcoulomb, Q2 equals to 300 microcoulomb. What happened after this? Now you combine them together. Okay, you put C1 and C2 together. So now you have a C1 right here. Okay, C1, which is equals to 10 microfarad. Okay, I'm going to write it like this. 10 microfarad. So this is your C1. okay, or C1. Now you connect it to C2. So C1 and C2, now you connect them together. So C2 is equals to 20 microfarad. If you look at the questions now it tells you positive facing positive, negative facing negative. Why is it so important to know which plate is being connected to which one? Well, it will tell you whether they are in series or in parallel. Same terminal being connected to same terminal, this is parallel. If you connect series positive to negative, then that would be a series circuit. Okay, that would be a series circuit. Okay, so when you connect them like this, what happens here is, if you notice, both capacitor now they come with different potential difference. Your V2 is equals to 15 volt, your V1 is equals to 6 volt. When there's a potential difference between two components, what happens? If you remember the things that I told you in lecture, when there's a potential difference, then electron will begin to move. Aha! Meaning that electron will start to move again in this circle. So how is it going to move? It's going to move from the one with higher potential towards lower potential. So your electron will begin to move. Okay, electron will begin to move. So it will move from higher potentials towards the lower potentials. So which means now your C2 will undergo discharging. Okay, it will undergo a discharging process right here, whereas your C1 will be charged. So charging process is happening in C1, meaning that V2 will drop and V1 will increase. And how are we going to identify? How are we going to determine the final value? Now let's see. So let us go back to questions A right here. The final charge stored in each capacitor. In order to determine the final charge stored in each capacitor, you need the final V, the final potential difference across both capacitors. So if C2 is being discharging, okay, and C1 is being charged, then V2 will drop and V1 will increase. We need to identify the new V. How? Well, again, if you want to identify new V, then you need to calculate the final C. So C effective, well, since they are being connected in parallel, it is equal to C1 plus C2, which is then equal to 30 microfarad. Then how about Q? Since you don't have power supply in the circuit anymore, so you won't have any extra charge in the circuit. So what we have is just Q total equals to Q1 plus Q2. So initially, you have this amount of charge in Q1, 60 microcoulomb. And then initially, you have 300 microcoulomb in Q2. And that is the total charge they have when you connect them together. Okay, that is a total charge, total electrons that you have, I would say. So Q1 plus Q2 equals to 360 microcoulomb. So you have this amount of charge in your final circuit, and then you have this effective capacitance in your final circuit. By combining the two of them, you can then determine the final potential difference across both capacitors. So V final equals to, V final equals to Q total divided by C effective. So you should obtain 12 volt. So once you have the 12 volt here, you then know that V final equals to V1 prime, which is the final, equals to V2 prime equals to 12 volt. So what does it mean? It means now this 6 volt is no longer exist, this 15 volt is no longer exist. When they achieve equilibrium state, the potential difference across them is now equal to 12 volt. All right. So by using V1 prime and V2 prime, as well as the C1 and C2, you can then calculate the final charge stored in each capacitor. So let's see. Q1 equals to C1 V1 prime. Okay, Q1 prime I would call it, because now we want the final charge. So Q1 prime is equals to C1 V1 prime. It is equals to 120 microcoulomb. Q2 prime equals to C2 V2 prime equals to 240 microcoulomb. So let's see whether we got the right answer or not by adding these two values together. Q1 give you 120, Q2 give you 240. When you add them up, they are equal to the total charge in the circuit. So yes, your answer does make sense. Okay, so it means that you got the right answer. Okay, it means that you got the right answer. So that is how you answer questions A by determining the initial charge, the charge stored in a capacitor C1, the charge stored in capacitor C2 before you connect them together, and then find out what happened after you connect them together. Okay, so after you connect them together, you got total charge equals to 360, and then Q1 equals to 120, Q2 equals to 240. When you add these two values together, they give you 360, which means you didn't make any careless mistake in your calculations. All right. So again, I give you 3 minutes to write it down before we proceed to questions B. Okay, and actually I think you are done calculating questions B as well because it's asking for potential difference across the capacitor. Without potential difference, you wouldn't be able to calculate Q. So basically you already have the answer, which is this one. This is the answer for questions B. All right, this is the answer for questions B. So you just rewrite it, or you can just write, okay, refers to A, and then you write the answer, okay, and then you write down the answer. So your V1 equals to, V1 primes equals to V2 prime equals to 12 volt. Done. Okay, done answering both questions A and B. So you write it down first before we look at question C, all right? 3 minutes for you to write it down. If you have any questions, you may ask. All right. So now let us look at the last questions. No, not the last question, sorry, next questions. Okay, question C. So question C is asking for the energy. Okay, the electric energy loss after combining the two capacitors. Because like I told you yesterday, when you charge up a capacitor, there must be an energy loss. Okay, because you need works to add more electron into negative plate. So work is being done to insert the negative charge into the negative plate. So what we want to see right now, we want to identify how much energy is lost in this process. Okay, in the second process, when you combine C1 and C2 together. So how? Well, by calculating the total energy before you connect them together and the total energy after you connect them together. So U before is equals to 1 over 2 C1 V1 square. You use the initial value plus 1 over 2 C2 V2 square. And then U final, which is equals to 1 over 2 C1 V1 prime square plus 1 over 2 C1 V2 prime, C2 V2 prime square, right? So if you got it right, your initial total energy should be equals to 2.43 times 10 to the power of negative 3 joule. Your U final should be equals to 2.16 times 10 to the power of negative 3 joule. Okay, so U before and U final. So once you have a both value, you can then calculate U loss by using U after minus U initial. Okay, U before, sorry, I use a final and before here. So U final minus U before, which is equals to negative 0.27 times 10 to the power of negative 3 joule. All right. So this is the amount of energy lost in your questions, example 4. Okay, in your example 4. So you look at the total. So how to calculate U total before? You calculate the energy stored in each individual capacitor, and then you add them up. That is the total energy before you combine them. And then total after you combine them, again, you calculate the energy stored in each capacitor, okay, and then you add them up. That is how we calculate total energy in a circuit. That is how we calculate total energy in a system. Okay, so same thing applies in chapter 1. You want to calculate total energy in a system, so you calculate the energy by each individual charge, then you add them up. All right. So I give you 2 minutes to write it down, then we'll move on to the last questions. Example 6. Okay, we'll move on to example 6. So again, this example 4, it involves a charging in one capacitor and discharging in another one. So 2 minutes for you to write it down. Okay, you calculate, make sure you try ya, see whether you can get the answer or not. Jangan salin saja, kamu cuba kira juga. Okay, kamu cuba kira juga. All right. So now let us move on to the last example, example 6. So example 6, now it involves just a discharging in one capacitor. All right, now you don't have two capacitors anymore. You're not charging one capacitor by using another capacitor. Now what happens right here, you charge with a power supply and then you discharge with a resistor. That's it. Okay, that's it. So in an RC circuit shown in the figure, the battery has fully charged the capacitor. So you charge the capacitor by using V node. And when it is fully charged, the keyword is fully charged, your VC is equals to V node, which is then equals to 20 volt. So at times t equals to 0, switch S is thrown from positions A to positions B. The battery voltage is 20 volt. That's why when it's fully charged, your VC is equals to 20 volt. And the capacitance given is 1.02 microfarad. The current I is observed to decrease to 0.5 of its initial value in 40 microseconds. Okay, so what are we going to do right here? Now let us sketch the circuit first. If the switch S is being thrown from point A to point B, which means the final circuit that we have, okay, this is your switch. Okay, this is your S, so this is your point B. So this is what we have at the final stage. Resistor, and then, oops, here is a capacitor. Okay, R, C, switch S, and the point B. So this is the final circuit. If you look at this final circuit, there's no power supply in our circuit. So meaning that now this circuit, this capacitor, it undergoes discharging process. Okay, it is being discharged. So this is a discharging types questions. So determines the values of R. So how to determine the values of R? Then we need to use the equations I equals to I equals to I naught. I equals to I naught exponential negative T over RC. Now why? What is the reasons I use equations with I? Because of the last statement. You are given the relationship before and after. Okay, the relationship of I before and after. Initially, you have I naught. And then it drops to 0.5 of its initial value. So you have I final. I final given is equal to 0.5 I naught. So you are given this statement. That's why I know in order to determine the values of R, I need to use the equations for I. So I equals to I naught exponential negative T over RC. I given 0.5 I naught equals to I naught exponential negative. Now time given, okay, so it's being discharged for 40 microseconds. So this 40 microsecond is my T, 40 times 10 to the power of negative 6 divided by R is an unknown, and then C given 1.002 1.02, yes, times 10 to the power of negative 6. I naught and I naught can be cancelled out. So rearrange the equation. Eventually, you should obtain R equals to 57 ohm. Okay, 57 ohm. So 0.5 equals to exponential. Remember, this is exponent, not the elementary charge, not electron. Okay, the E in a discharging process, it represents exponential. Jangan keliru, okay? Ada pelajar dia pergi substitute dengan nilai elektron. No, that is wrong. This should be exponential. So the time constant tau, okay, how to calculate time constant? Well, time constant, you have these equations. Tau equals to RC. R from questions A is 57. C given 1.02 times 10 to the power of negative 6. So final answer is 5.8 times 10 to the power of negative 5 seconds. Okay, 5.8 times 10 to the power of negative 5 seconds. Now let's look at question C. Question C asks you to calculate the values of charge on the capacitor at times t equals to 0. So at times t equals to 0, well, we have a fully charged capacitor. Okay, so at times t equals to 0, my capacitor is still fully charged. Okay, it's still fully charged. So when it is still fully charged, what does it mean? It means we have maximum amounts of Q in our circuit. So we want to identify the values for Q naught. In order to calculate Q naught, we need to use maximum voltage at that moment. Okay, so because C is a fixed value, so Q naught equals to C. So V when it is fully charged, which is V naught. So when it is fully charged, we have 20 volt. So Q naught is equals to 1.02 times 10 to the power of negative 6 times with the 20. Okay, when it is still fully charged, so you use the potential difference when it is fully charged. Okay, you need to charge Q naught, you use V naught. If you want to calculate final Q, then you use final V. Okay, final Q, you use final V. So this is equals to 2.04 times 10 to the power of negative 5 coulomb. When it comes to questions D, the values of Q at times t equals to 60. Now you are given a new time. Okay, you want to calculate final Q. Now try to think first. Do you have final V? Are you given the V at times t equals to 60 microsecond? Obviously no, right? Because question just gave you an initial V. It doesn't tell you anything about the final V. So what you can do is by using the equation for discharging process. You cannot use Q equals to CV anymore because you are not given final V. If you are given final V, then that would be a different story. You can straight away calculate it by using Q equals to CV. But now since you are not given final potential difference, then you need to use the equation for discharging process, which is Q equals to Q naught exponential negative T over RC, right? So initial Q, you have 2.04 times 10 to the power of negative 5 exponential negative. Now times given is 60 microsecond. So 60 times 10 to the power of negative 6 divided by RC. RC is your tau. Okay, this RC is equals to tau. Therefore, you can use the values from questions B. Okay, so questions B, you have this value. Tau equals to 5.8 times 10 to the power of negative 5. So 5.8 times 10 to the power of negative 5, which is then equals to 7.3 times 10 to the power of negative 6 coulomb. So that is the answer for questions D. Now, of course, if you don't want to write it as 5.8 times 10 to the power of negative 5, you can still rewrite this whole thing. 57 times 1.02 times 10 to the power of negative 6. Nothing's wrong. Okay, nothing's wrong. This is just a shortcut. 5.8 darab 10 kali 10 negatif 5, ini cuma satu shortcut sebab Anda sudah kira di soalan B. Tapi kalau Anda rasa dia akan mengelirukan Anda nak tulis semula 57 darab 10 darab 1.02 darab 10 kuasa negatif 6, boleh juga, okay? Boleh juga, tak ada masalah. Saya cuma tunjuk Anda shortcut. Alright, I'm just showing you the shortcut so that you don't have to key in so many things in your calculator, so that you don't have to recalculate it again. Okay, because basically you have done it in questions B. Alright, so that is your example 6. So now we are done with 3 questions for this slot. Okay, I will keep the 3 more questions for 12 to 1 p.m. Okay, we will join another class to finish the other 3 questions at 12 p.m. today. Alright, so if no questions, you write it down, then you may leave the class. Kita akan sambung lagi pada jam 1.